So when we talk about the properties of materials, there are two types of materials. There's a general rule that we'll focus on initially. One of those is conductors. And so a conductor is a material in which the electrons can move freely in response to an electric field. And the best example we have for conductors are metals. Insulators, on the other hand, the charges aren't able to move freely in response to an electric field. They're bound to the structure of the material. So these are things, insulators are made out of things like plastic, wood, glass, rubber. Right? So if you want to think about the picture here, so let's say I have a spherical conductor. And if I have some positively charged rod that I bring close to the conductor, the electrons on the conductor are able to move in response to that rod, and so they will move so that there's a predominance of electrons on one side of the conductor. Right? They're able to move around. Those free electrons are able to move around. If I bring that same metal rod, or that same charged rod up to next to an insulator, again, because those electrons are bound to the material, they're not able to move around as much. So what happens is I can polarize the material, but those electrons can't get over where they can on a conductor. They're just not able to move around the way they can on a conductor. So the same property happens for the same reason with heat. Right? We know there are objects that conduct heat well. We know there are objects that conduct heat poorly. And the things that conduct heat well, again, have the ability to transport that energy as heat through these charges that move around. So two ways to charge a conductor. And one of them will give me the same charge at the end. The other one's actually going to give me the opposite charge. So if I charge by conduction, so basically this is the idea that, let's say I start with my rod and I bring it close to my conductor. Well, again, I know as I bring it close to my conductor, those electrons, those free electrons on the conductor, are going to move over in response to the electric field created by the positively charged rod. And when I actually touch them, some of those electrons will move to the rod. So they'll leave the conductor and move the rod. Well, what that means is two things. One, in leaving the conductor, they're going to leave the conductor positively charged. There's now more positive charges on the conductor than negative charges. Two, in moving to the rod now has less positive charge than it had before. So charging by conduction through that contact, providing a pathway for those electrons to actually literally leave the conductor and move to the rod, it leaves the conductor positively charged and diminishes the charge on the rod. Charging by induction, on the other hand, is I'm not going to provide that same pathway. What I am going to do, or at least not between the conductor and the rod. So I'm going to start with my same positively charged rod. I'm going to bring it up to my conductor. Again, I know that those negative charges are going to move over in response to that rod. But now what I'm going to do is connect my conductor to a ground. And what that ground is going to allow is it's going to allow additional electrons to move up from the ground onto the conductor. So instead of getting rid of electrons, what I'm actually doing is moving the electrons over so that more electrons will be attracted from the ground, which of course leaves my conductor now with an excess of electrons. So my conductor is now negatively charged. So notice that when I charged by conduction, I used a positively charged rod and got a positively charged conductor. When I charged by induction, I used a positively charged rod, but it left my insulator negatively charged. So I created the opposite charge on my conductor.